We will discuss our experimental procedures and results in determining the amount of caffeine and benzoic acid in a commercially bought soft drinks. This will also highlight the use of high-performance liquid chromatography or HPLC. First, what is liquid chromatography? It is an analytical technique that separates the sample into components. Upon separation, with the aid of light, components could be identified and quantified. The major parts of an HPLC system are as follows: solvent reservoir, binary or quaternary high-pressure pump, HPLC column, sample injector, and detector. The diagram of HPLC system is displayed on this slide. Solvent, also known as the mobile phase, which is aqueous and moderately polar liquid. In this experiment, a 60-40 ratio of methanol to water is used as a solvent. It will serve as a medium for the sample to travel across the instrument, and it will go towards the pump, which will force the solvent through the entire instrument. The injector is where the sample will be introduced. HPLC column, which contains the non-polar to less polar particulates, will separate the sample into its components. The less polar components will travel the column longer than the polar ones. The UV detector and the data processor will analyze the components and the output. The chromatogram will describe the retention time and signal emitted by each components. The instruments to be used are Agilent 1200 series high performance liquid chromatogram, ATY analytical balance, and a sonicator. The sample that was analyzed is Coca-Cola in a 330 ml can. The label declared a 34 mg of caffeine and no benzoic acid in each servings. The solutions to be prepared are as follows: test sample solution, blank solution, 100 ppm caffeine standard, 50 ppm benzoic acid standard, and a system suit standard. For the test sample solution, carbon dioxide and other gases were removed by heating. 10 ml of the cooled and filtered samples was diluted up to 100 ml mark. Using a syringe filter, 1 ml of sample solution was transferred to the HPLC vial. Blank solution was distilled water. It is still necessary to filter the blank solution to avoid any penetration of particulates. 100 ppm of caffeine standard solution was prepared by dissolving 100.3 mg of caffeine in a 100 ml flask, then diluted to mark, using a sonicator if necessary. 5 ml of the solution was then transferred to a 50 ml flask, then diluted to mark. 50 ppm of benzoic acid standard solution was prepared by dissolving 50 mg of benzoic acid to a 100 ml flask. Use sonicator if necessary before diluting completely up to mark. Transfer 5 ml to a 50 ml flask, then dilute. For the system suit, 5 ml of 100 ppm of caffeine was then mixed with a 1 ml of 50 ppm benzoic acid in a 100 ml flask and then diluted to mark. Transfer to a HPLC vial using a syringe filter. Analysis will be carried out using Agilent 1200 series HPLC. The set parameters are 254 nanometers and 1 ml per minute. The peaks in this chromatogram are the solvent peaks that appears on a 2.506 to 2.686 minutes. Caffeine peaks appears at 6.826 minutes. System suit only shows the peak for caffeine. Unfortunately, benzoic acid was not accurately shown due to a wrong stop time. Results show the presence of caffeine. No benzoic acid was observed from the sample. Standard response of caffeine was shown on this table. The average standard area is 125.445 millivolts. Standard deviation is 0.17 and percent relative standard deviation is 0.14%. Using 1-point calibration, the concentration of caffeine on test samples will be determined. The average sample area was 290.685 millivolts, standard deviation is 0.26, and percent relative standard deviation is 0.09%. Relative error was calculated to be 0.128 at 95% confidence level. The experimental amount shows a significant difference with the declared amount. Caffeine in a can of soft drinks yielded a 38.3493 mg per 330 ml of Coca-Cola can, which is 112.79% of the 34 mg per 30 ml Coca-Cola can label claim and with relative error of 0.128. There is a significant difference between the experimental result of caffeine and the declared amount of Coca-Cola label. Benzoic acid was not accurately determined due to wrong stop time, and the analysis was not fully optimized at that time. Analysis of the chromatograms shows that the sample does not contain benzoic acid as there are no peaks detected.